So we're at days in a month. This is your last program, your last regular program for Computer Science 1. So I'm just going to intro this quick. I'll talk you through this, and then you'll be able to work on your hierarchy chart for it. Okay, so here we go. First bullet says, given an integer that represents a month, January would be 1, February would be 2, all the way to December being 12, and an integer year, determine the number of days in that particular month. The input for this program will be provided in the file months.dat. So if I show you that real quick, just like the last program, it's going to be a file reading program. So you're going to have to find your Computer Science 1 folder and go to Input, select months.dat and copy it. And when you make your project, you're going to paste it on the folder, days in a month, and months.dat should pop up at the bottom. Here's what the file looks like. So like I said, you're just taking an integer that represents a day and a year, and you're supposed to say how many days were in that month. Usually either 30 or 31. February is the weird one. It has 28, except if it's a leap year, it's got 29. Your solution must use a switch statement. Okay, so it pretty much depends on what month it is. If it's January, January always has 31 days. February is the weird one. March always has 31. If you don't know how many days are in a month, first of all, that's shameful, but use your calendar on your phone and look at how many days are in each month. But you can't use an if statement. You can't say like if month equals 1, print out 31. You have to use a switch statement and think about what variable you're comparing every time. It mainly depends on the what that would go in your switch statement. Your code must use integer constants named after each month in the cases of the switch statement. Okay, now this is just for readability. Let me explain that. So if I open this up real quick to show you. So month is the variable that we're comparing. So again, there's 12 cases because there's 12 months. So we did the switch statement notes in the last video. So hopefully you still have those. But you're going to be in some method, you're going to be doing a switch statement on the month. You could just say, so this means if month equals 1, print out 31. Else if month equals 2, print out whatever you're going to do here, etc. But just for readability, instead of seeing 1, 2, 3, all the way down to 12, these cases mean actual months, January, February, March. So I want you to make integer constants. Remember how to make a constant? You use that word final. So final int, constants have to be capitalized. So January, February, March, all the way down to December, these are constants that aren't going to change, but each of these words, these months, are variables. January equals 1, February equals 2, all the way to December equals 12. So when I say I want you to use integer constants in the name of the case statements, instead of putting 1, 2, 3, 12, you can put those constants, January, February, March, December. It makes the code a little bit easier to read. It just reviews the concept of constants a little bit. But since January is a variable that equals 1, this means the same as case 1. And since February is a variable that equals 2, that means the same as case 2, etc. So that's basically what that bullet means. Okay? Ask me if you have any questions about that. In your output, print the month and the year in addition to the number of days. So I don't want to see like 1/2006. I want to see January 2006. It should be easy to determine the number of days in all months except for February, assuming you know how many days are in a month, which you should because you're a high schooler. But if you don't, use your phone and look. Use the following information about leap years to determine the number of days in February. It says, according to the Gregorian calendar, which is the civil calendar that we use today, years evenly divisible by 4 are leap years. That'd be easy if it stopped there. But it says, with the exception of centurial years, so any year that's divisible by 100, that are not evenly divisible by 400. So therefore, the years 1700, 1800, 1900, and 2100 are not actual leap years, but 1600, 2000, 2400 are, because those are century years that are divisible by 400. Okay, so read that over a few times. That's kind of confusing. in the case for February, it's kind of like, remember in our notes when we did the case, when we were doing the grades, and for case 6, if we were in the 60s, we had to have an if-else in that case. If it was greater than 65, it was a D, else it was an F. In the February case, you're going to need a series of if-elses. So if it's divisible by 4, might be a leap year, but you also have to check if it's a century year. So think about how you're going to do maybe a nested if-else loop or just a series of else-ifs to figure out how it's a leap year in February. And if you get totally stuck with that, you can obviously come to me for help, but that's really the only tricky part of this program. Okay, so let me show you the program running. So there's all my days and months. We're going to need a while loop, so use your file read test again. Remember file read test. You'll have your variables. Think about the variables you'll need to read in from the file. You're going to need a variable to store that and that for every case, or every time through. In your run method, months.dat is the file you're going to be using. You're going to be reading in the month and the year. You should have some kind of calculate method, and you should have some kind of print method. There's not going to be a final print, because when I run this program, it just prints out your regular heading like usual, and it says each of the months from the file. Now again, it doesn't say 1/2006, it says January 2006, so you'll have to print that out, and it prints the number of days. So it does that for all of them. And when you check your output, you might want to take a picture of this screen right now so you can check your output later, or use the black binder. Be careful about February. February is the weird one. So make sure you're printing out the correct number of days. Like February 1996 has 29 days. That's because it's divisible by 4. February 1600 also has 29 days. And that's because it's a century year that is divisible by 400. But when you look to February 1000, that's divisible by 4. All century years are. But it's a century year that's not divisible by 400. So that's only got 28 days. Of course, anything not divisible by 4 in a year not divisible by 4 in February also has 28 days. All right, so hopefully that gives you a good thought of how to do this. Again, if you have any questions, call me over before you start your hierarchy chart, but otherwise, get your hierarchy chart written, have it checked by me, and write up this last program. Good luck.